Yeah, I'm just recording myself. Okay, so today what we are doing is on your lab 3. So we are doing on your lab 3 itself, which is your binomial distribution and your normal distribution. Okay. Okay. Okay, so we are going to do this. Now, when do we, because we have not gone through a tutorial yet, when do we use binomial distribution? No idea? Okay, so essentially, let's say, for example, you have a test. Okay, your test is maybe like 20 MCQ questions. Each MCQ, how many choices do you have? Each MCQ, how many choices? Okay, so you have, assuming that you have 4 choices per MCQ. Okay. Now, assuming that you do not know what the paper is talking about, you never study or whatever thing, what is the probability of, let's say, you get maybe like 15 marks? Or what's the probability of getting like maybe probability of getting 12 marks? That you can use your binomial distribution to help you. Okay. So the binomial, so in this case, n is 20 questions. The probability, if you have 4 choices MCQ and you randomize it, that means you pick at random, the probability of getting correct is 25% of a chance. Okay, and you want to find out, you want to get 12. So this is your R. So the general equation for binomial distribution is your n. Okay, so using a combination, what? Yes, correct. Bernoulli trial is a experiment that's only 2 outcomes. It doesn't mean that the 2 outcomes has to be evenly distributed. That means 2 outcomes, it may be you get 90% wrong, 10% right. The 2 outcomes doesn't mean that you need 50% correct, 50% wrong. Just that there's 2 outcomes. That's called Bernoulli's trial. Okay, so each MCQ becomes a Bernoulli's trial in a sense. Either you get it right or you get it wrong. There's no half. Okay. Then what you have is you multiply by the probability of success to the power of R. Q is essentially the probability of failure, which is 1 minus P. Right? So we say that is 1 minus P, to the power of n minus R. So let's say you want to calculate, so this is the general equation to begin with for binomial distribution. Now, what this also means is, if you calculate the probability of getting 0 marks plus the probability of getting 1 mark, all the way to the probability of getting full marks is going to be equals to 100%, right? You're always going to get between 0 to full marks. That's what it means. So you can actually do that in a sense. In our case here, the probability of getting 12 marks is then given by this equation, 20, 12. Probability is 0.25 to the power of R, which is 12, and 0.75 to the power of 8. So that you use your calculator, you can find out. What we are going to do now is how do you use how do you use Excel to find out? Okay. All right. So that is one thing about binomial distribution. Binomial distribution, you can only use binomial distribution if each of the trial doesn't affect the probability of success. That means every question is independent of each other. Okay, that can be a bit subjective, yes. Every question, the probability of getting right is the same. That means every question you have only 25% of getting it right. Okay, it is as good as asking your dog to go and answer MCQ questions. Okay. So how do we do that in your Excel in itself? Let's try it. Huh? It's recorded. You can go and take a picture from it. Okay. So we can actually use, for example, you have the total number, in our case, total number of questions. So that is your N. Okay, let me explain this. So total number of questions, that is your N. In our case, just now we have 20 questions. The probability of success, okay, probability of correct answer, which is the P, in our case is 0.25. Okay. Now what you want to find out is, what is the probability of getting 12 marks? Okay. Okay. The equation or the formula is equals to binomial distribution, binomial dot distribution. Okay, and you open. So number of success trial. Number underscore S is number of success trial. In this case, it's 12. Okay. Total number of trials is 20. Right? Total number of trials is 20. Probability of success is 0.25. The last one asks you cumulative, whether you want to use a cumulative distribution function or a probability mass function. So if you want to find only for 12, then you say that that's false. If you say, if the last option you put true, right, it means that you're finding what is the probability of getting up to 12 marks. So it's actually accumulate 0, 1, 2, 3, 4, 5, all the way to 12. Make sense? So the probability of getting exactly 12 marks is pathetic. Correct. So the probability of getting exactly 12 marks in this case is 0.00075, which means that is 0.075%. Okay, so that is the function first. All right. Yes, what? Why is that now? What do you do? Zero point zero, not 0.0. Make sure that you have only 4 variables. Okay. So you can also do, what is the probability? Okay, try now yourself. What is the probability of getting full marks? Try this. What is the probability of getting full marks? Assuming that you just ask your dog to do a multiple choice question. Yeah, false, you have to put false. The probability of getting full marks is that low. Okay, what does this mean? In Excel, what does E means? Okay, you see something like this, 9.09 E minus 13. Okay, this is in Excel. What does it mean mathematically is 9.09 times 10 to the power of minus 13. E means exponent. So how low is this chance? But you have to have some measure, some estimation. How low is this very low? What is some of the random chances you have in Singapore or in developing world, developed world, or whatever thing? Cancer, I actually don't know what's the chance, what's the rate, because it varies with age. Okay, lightning strike in Singapore. If you are in Singapore, your chances of being struck by lightning is about 1 in a million. So it's 1 times 10 to the power of minus 6. Yes. Lottery, you can count yourself. Okay. So depending on what kind of lottery are you talking about. If you 4D, if you really want to buy everything, 4D, you end up with 43% chance of being striking something, of winning on average. So it means that for 4D, for every dollar for a long time, right? For every dollar that you put in, you get back 43 cents. Yeah. Don't worry, I calculated that before. Okay. Now, okay. So you have to 1 times 10 to the power minus 6 is definitely much higher than this, right? Another way to look at it is 1 times 10 to the power of minus 10 or 10 billion is about one chance in the lifetime of this universe. Okay. Doesn't mean that it will not happen, just a very low chance. Because everything is probabilistic. When we talk about normal distribution, especially for tutorial on Thursday, the line doesn't touch the x-axis. That means it goes to infinity. Which means that everything can happen if you try hard enough. If you try very hard, it may be way beyond your life, it will still happen. So let's say if one of you who has a very sturdy head, any one of you have a very sturdy head, that means you can bang the wall all day long. Okay, let's say Tong Tai. Sturdy, for example, you know that every time he runs onto the wall, he's going to bang onto the wall, right? Most of the time. Most of the time. Okay? Because the probability curve doesn't touch the x-axis, which means that it can be infinitely tiny. So if you were to do that infinitely amount of times, there will be some chances that he'll appear on the opposite side of the wall. He'll get through the wall. That's what it means. Okay? Structurally, actually, that's quite possible. That is in terms of quantum physics, that's actually possible. Okay? That's it. Yeah. Okay. So anyway, let's look at this question by itself. Okay. So when you take this and you say that the back end is true, let's say you take this, right? And you change the false into true. Okay. This means that the probability of getting less than 13 marks. That means including of 12 marks. So it's actually very high. because it's up to 12, inclusive of 12. So it's actually, yeah, what you are supposed to write is actually this, Px that is less than or equals to 12. So it's actually less than 13. Okay. So now, which also means that if you do your random multiple choice questions, you want to pass, you need to get at least 10 marks, right? Correct? So you say that P, you want to get at least 10 marks. So the probability in this case is at least 10 out of 20 marks. So it is 0. It's actually 1% chance. 0.99. 0.099, which is actually 0. So I just change this. Yeah, I just changed the first one, the value to 10. 10, 20, 0.25, false. So I accumulate it. But correct, this is the number of success. The total number of trials. Chance of success. Yeah. Okay. So once we have this, yes, what? Louder, I can't hear you. At least 10 marks, also inclusive of 10 marks. Yeah, at least 10 marks. So we can actually do this for testing. So for example, I want to calculate my marks. So my marks is actually the R, right? The number of marks is R. So let's say now, okay. So I want to have 0 marks, 1 mark, all the way to 20 marks. So I drag all the way to 20. Okay, 1 to 20 marks. And my total number of questions is actually my n value. I have 20 questions in total. All right. Yeah, so it's possible to get 0 marks, as much as possible to get 20 marks. Okay. Just drag. Have 2 numbers and drag it down. Okay. Questions. Okay. So then my probability of getting correct, which is here my p value, the p itself. So here every question is 0.25. Okay. Remember, for a binomial distribution or binomial distribution, the probability must be the same. Cannot change. Okay. Just type in yourself. Yeah. Otherwise, you highlight 1, 0 and 1, and then drag it down. Then no choice, type in yourself. Your computer doesn't like you. I can't do anything about it. Yeah. So later we're going to do up to 50, so don't worry. Okay. Then we want to find out the probability of your x equals to r, correct? So you want to do that for everything. So you can use the same equation, binomial distribution. Okay, success S itself is trials 20, probability of success, and false. False. Doesn't matter. Yeah. Okay. So I put this. So the probability of getting 0 marks is actually 0.3%. Okay. Then I can do the same. Just drag it down and calculate what is all the probability of getting the relative marks. Okay, okay so far. Okay. Then you can even plot. You can plot column A, the marks, versus column D, the probability. You insert a scatter plot. Try to insert a scatter plot. Then this is the probability of marks that you're going to get. Huh? Okay, hold on. Press Control, select A and D. Okay, make sure you select in the correct order. You select D and A, then the X and Y axis become opposite. Okay. So insert scatter plot. Okay. All right. So it means that if you look at here, on average, you will get about 5 marks. The highest probability, about 20%, you'll get 5 marks. Right. So this is how, but up to you. What do you mean for study or not? Yes. So this is just, we are looking at just random chance. Random chance first. Okay. So what thing? For yours, you will have to do the reverse. Like this, control. Like this. Release the control. You remove your control. So you highlight A, control, highlight B. Oh, yes. No, not true. Use false. Use false. All right. So based on this, let's say pure multiple choice question, and you're just asking random. What's the easiest way to make multiple choice question tougher?
Put all the same choice.
More choices. All right. You can put more choices. So let's say you look at it this way. What you need to pass a 20 MCQ is at least 10 marks, right? So you can just, at 10 marks here, you can do a sum for all the 10 marks and below. Okay, do a sum for all the 10 marks and below. And you'll find that the probability for a 4-choice MCQ is 1.4%. Sum. 1.4%. Yeah. So 1.4% that you will pass the test if you just pick your answer at random.
I'm wrong.
Okay. Now this scatter plot. This 2D line, wrong. Scatter plot is this. Yeah, that's one. Okay. Sum of 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. sum of the probabilities. Yeah. Okay. All right. Yes. Rob? I like this. Yeah. Okay, so what happens if your 20 MCQ is just true false question? Do you think you have a higher chance of getting or passing? So why not you, which number do you have to change if it's true false question? Just the probability, right? So you change column C to all 0.5 for true false question because it's yes and no. And you'll find that from 1.4% chance of passing, you go up to 60% chance of passing. Okay? This is why we don't give you true false questions. When I give you true false question, it also usually means one thing. You get correct, you get 1 mark. You get wrong, you minus 1 mark. What? Okay. Okay. So similarly, how do you make MCQ question harder? More choices, correct. Yeah. Okay. Now, don't always assume in your life that MCQ must always be 4 choices. Yeah, 5 choices. Okay, try 5 choices, see what happens. So 5 choices is 0.2. Okay. The worst I've seen so far is A to J, 10 choices. Yeah, that's for university. No, A to J, and the question is you have 50 questions to do in 1 hour. That is 50% of the marks of the module. Not for me. But when you go to university, depends. You may have. Why not? The choices could be which of the following statement is true. So I have 5 statements. Statement 1 is true, statement 1 and 2 is true, 1 and 4 is true, 1 and 3 is true, 1 and 4 is true, but 3 is not true. All these different things. Okay? Yeah, so this is the distribution. Because the probability is very low, look at 9.5 times 10 to the power minus 7. Do you think it's ever going to show here? No. Okay. All right. So the next thing is, how many of you want to take your want to learn driving? You want to learn driving. So what's the first thing you need to do? Why you need to bother about getting a girlfriend when you want to drive? Okay. So driving, what's the first test you must go through first? Okay, your theory, your basic theory. What is the criteria to pass? How many questions are there? Huh? Okay, you have 50 MCQ. Okay, 50 MCQ, 4 choices, How many marks to pass?
46.
46. You can only wrong 5. So let's do that and see what happens. Okay. So you can do the same, just that now you just drag these numbers all the way to 50. And Daniela, you probably have to just type it yourself. Okay. Number of questions, instead of 20 must be 50 now. Okay. Probability of correct is 0.25 again. Okay. Doesn't matter if you are slow. Okay. What number? Yeah, because just now the number is in running order, but doesn't matter. Okay. So then this is your probability. So if you go all the way to 46, 46, 47, 48, 49, 50, you do a sum. That means you never study anything at all and you try to pass. That is not going to happen. What do you mean what I do? I'm drinking water. Sum. The sum of 46, 47, 48, 49, 50, the probabilities. So it's not going to happen, basically. Okay. Yes. Everyone must change at the end. That doesn't work. So if you actually look at it in a different way, when the number of trials becomes infinitely large, it actually looks like a bell curve. Looks like a normal distribution somehow. Because, click on it, it only goes up to 20. Okay. All right. Yes, what? Okay. That means if you actually do the basic theory without studying, without even knowing the question itself, you are going to be roughly about 10 to 12 marks here. That's the most likely probability. You have about 13% chance of getting around 12 marks. That's way off from your passing point. Okay. All right. Now, with that, we can do your normal distribution. Now, actually, most of the statistics that you're going to do for the up to, I think, the last two lectures is all this thing called parametric statistics. which means that the data should be normally distributed first. That means does the data follow a normal distribution? So we are going to check if the data follows a normal distribution. Just that Excel doesn't have a normality test. That means there's no statistical test in Excel tells you whether it's normally distributed. That, however, you can ask Excel to kind of calculate something known as a quartile plot or QQ plot. Okay. The QQ plot will tell you does it look normally distributed or not. Yes. So QQ plot, the standardized versus the z-score should be a straight line. So now we actually do the QQ plot now. Okay. So this is the one that you do step by step. It's very easy to mistake. And we are going to do the check whether the waste from our diabetes data set is it normally distributed. So let's go to your diabetes data set first. Get the diabetes data set and grab the waste data. Get the entire column, copy, go to your spreadsheet for today. Waste. Okay, waste. Copy, copy and paste onto your spreadsheet. Yeah, on today's spreadsheet. Okay. So what you're going to do is there's a series of steps, but this is a standard steps for you to do the quartile plot in Excel. Okay. So you actually have it in a page 3 of your notes already. So let's go through it. So the first column, column A, you have your data to begin with. At B1, you type this thing called rank. So you want to rank the waste data. That means from smallest to largest. If there are ties, you have to add up and break into 2. So ties will give you maybe like 7.5, 7.5. Understand? 2% of the same waste, you actually use the same rank, but you divide by 2. Just like 2% scoring third for exam. So there's no 4th place. It's 3 and 3. So it's actually each one is 3.5. Okay. So you want to rank it up. And you want to, because if you want to break the ties, you have to use this thing called average rank. Remember, average of itself is itself. Average of 2 numbers is the average of 2 numbers. Right. Average of number 5 is 5. Yeah. Average of 5 and 6 is 5.5. Okay. So you use this thing called rank average. Okay, rank average, you want to rank the data point, which is the waste itself. So A2. Then what you want is you want the column. So where is the reference column? Now, reference column, you click on A2 again and press Ctrl Shift down. So it highlights the whole thing for you. Otherwise, you can type in A2:399. Okay. You comma, it gives you 0 for descending. That means from largest to smallest. Now we want ascending, smallest to largest. Okay. So waste number 29 is position number 16, rank number 16. That's what it means. Yeah. Okay. But this part, you cannot drag down first. What happens if you drag it down? If you drag down, what happens is you find that the reference, that means the reference of people will change as you drag down. So you want to lock the value as it is. In order to lock the value as it is, you want to lock the the row position, not the column position. So to lock the row position, you put $sign in front of it. So just follow is what I do. So $2 colon $399. All right. Once you have that, when you drag down, let's say you drag down a few, you realize that the reference range doesn't change anymore. It get locked in position. Okay. So then just drag down the whole thing. Correct, 0.5, because it means that there are two persons that are with waist size of 33 inches. So it's position number 33 and position number 87 and 88. So divide by 2 is 87.5 each. Huh? Okay. Okay. All up to here? All done? Now you have to do step by step. So the next step is you want to convert the ranks into percentile. Okay, so you need to know the maximum rank so that you can convert it into percentile. Okay, so you column C, you put it as percentile. Okay, and then percentile is basically equals to open bracket B2, you minus off the 0.5. Minus off 0.5 first, then divide by the count. Okay, in this case, just do the same as what you have, but you want to lock B2 and 399 in place. Okay, you want to lock B2 and 399 in place. Huh? No, just follow accordingly. Yeah, because the 0.5 is for the tier, the ties. Okay. Yeah, because there's three. Just type in yourself. Okay. Minus 0.5 is because of the ties, the tie ranks. Okay, so once you have it, make sure go and pull down the entire column so you get something like this. So this is percentile in the sense that 1 is the maximum. So meaning waist size number 46 inches is actually at the 90th percentile already. Okay. Top 10%, the highest 10%, correct. All right. So all of you able to get up to here? At least able to do this part first. So the step is, this is actually a process. You can do that for any data set, it doesn't matter. This is a process you follow. Okay, it's a procedure. Okay. The next one, you have to calculate this thing called the Z-score. Z-score, you will do it in tutorial this Thursday. Okay. So Z-score is actually you want to tabulate based on the normal distribution. Z-score is the standard deviations, the number of standard deviations. No, it's more complicated than that. Okay. So what you need is you want to calculate convert the percentile into the Z-score. Okay. So convert the percentile into the Z-score. Just type in this, your normal inverse function. Click on the percentile. Okay. The mean is 0. The standard deviation is 1. Later I'll explain to you. It means 0, standard deviation 1. So that is the Z-score. Okay. So what does this really mean is, if you look at the normal distribution is on the Z-axis. The mean is actually 0. Okay. The standard deviation is 1. So minus 1, 1, 2, 3, and so on. So it's minus 2, minus 3. Okay. What it does is, here 0.03984. So basically I'm asking Excel to actually tell me if I have the area. If I have the area that is, and this area is 0.039 what? 3984. 3894, yeah. 3894. 3894. What is the value here? So it's actually minus 1. What do you get? 1.763. Okay. Normal inverse. Okay. Okay. So now we have that. Then you can settle the Z-score column. Okay. So the last one is column E. We have to convert the waste into a standardized waste score. So you call this as a standardized waste. So essentially, just follow accordingly. You take the value minus of the average of the waste itself. Individual waste minus of the average of the waste. Divide by the standard deviation of the waste. Okay. Huh? No, I guess my close bracket is a numerator. Numerator is a close bracket. So you get here minus 1.55. So this is where you can, the z-score is actually the data point minus of the average divided by your standard deviation. Huh? What's that equals? This is the data, this is the average. You convert every value into the z-score of itself. Your z-score shouldn't have number error. That means you put the wrong thing inside already. Okay, so once you're done, just complete the entire column. Okay, so now all the calculation is done. What you need to do is to plot the values out. All right. So you just check a few rows and make sure you get the same values as me first. Okay, let's check a few rows. Then the next step is to plot column B, your z-score, and the standardized base into a scatter plot. Column D and column E, you plot it into a scatter plot, you get this. D then E. Okay. So the criteria for normal distribution on a QQ plot is this. Okay. If the data is normally distributed, it will fit two criteria. Number one is the z-score versus the standardized value is more or less a straight line. Okay. More or less, that means if it's more or less a straight line, that means you can plot it into y equals to mx plus c. Or in this case, you plot it to z-score equals to m of the standardized value plus c. Okay, it should fit a straight line. The second criteria is once you plot into a straight line, the gradient should be close to 1. Okay, so at least from our plot, it's almost like a straight line already, right? So the next thing is to check whether it's a gradient equals to 1. So all you need to do is to click on the data points, right click, add trend line. Okay, add a trend line. You add a linear trend line because that's y equals mx plus c. and you show the equation on the chart itself. You can change and you see that the gradient is 0.9966. So it is nearly equals 1. Okay, so it measures, fulfills both criteria. Yes. Huh? Yes. Okay, but this is a visual and rough and quite a heuristic way. The more precise way is actually there's a normality test. But if you don't do it in Excel, Excel doesn't have that. Yes. The bracket is here. Right click. The data point. Data point. Data point. Down. Action line. Okay. Go down. Go down. 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 Show equation. Equation on chart. This is equation on chart. Okay, so it fulfills both criteria. Roughly is looking normally distributed. Now, when you use R and all this, there's actually normality test. And also, have you saw already? Huh? Yeah, R studio. Okay. All right. So this is your QQ plot essentially. Okay, the next thing that we want to do is doing something similar to your binomial distribution, looking at your normal distribution itself. Okay. Now, normal distribution, we want to see a few things. One is this. Let's say a normal distribution. Okay. All right. The question is this. Let's say this is the frequency. We have covered this already. This is the frequency. Okay. And then this is frequency, the count. Okay. If you have an equation to describe the frequency polygon, so we can actually have an equation to describe the frequency polygon. This is your fx. How do you find, what is the mathematical method of finding area under the curve? You integrate it. Yes. Okay. What is the purpose of finding differentiation? You find gradients. Okay. So your area under the curve is actually the integration of your fx itself. Now, and if we say that the total area under curve, we set it to like 100%. That means equals to 1. It means that the area under the curve becomes the probability of something happening. So far, so good. The area under the curve is the probability. Okay. So now, can I actually find out? So this is normal distribution. The axis doesn't touch. The line doesn't touch the x-axis. Okay. Now, let's say this is the mean here is maybe say 150 cm. The standard deviation is 22 cm. Let's say this is all heights. Can I find out, let's say 125? What is the probability of getting somebody that is 125 centimeters and below? That means I'm actually finding the area of my blue shaded area. The blue shaded area, basically. Okay. So mathematically, how do you solve this? Based on your integral. For those who have done AMS before, how do you do it? There is the range, right? You need the two numbers here, the two range. So basically the probability, because it doesn't touch the x-axis, in fact, it can go to minus infinity. But assuming that height is there's a 0, right? So the probability is actually you go from 0 to 125. Which one? Integration. Huh? What? Yeah, then you have a dx. Okay. That's a differential. Okay. So if you have not done, if you forgot this totally, is still fine. You can go and ask your engineering friends. They're probably crying doing this already. Okay. Now, can I, let's say, I want to find exactly 160. What is the probability of 160? So, yeah, the probability of height equals to a very specific number, 160. The probability is actually 0. Mathematically, why? Because what happens when you do this? 160, you minus off, it becomes 0. Area line, a single line has no area. Correct. Met on this chart. Fundamentally, we have to remember a definition of a line is a breathless length. A line has no breadth. The breadth is 0. It has only length. We don't 0 breadth. Therefore, there's no area. Okay. All right. So far. Yeah. Correct. You can do it for a range. Yes, correct. So binomial, you can find the probability of a single item or a single number. Normal distribution, you can't. Okay. So far, at least the math is all right. Okay. So why do you need to learn this part? Okay, in fact, maths itself, your integration differentiation is out of the syllabus, out of your diploma for a few years already. Okay. 2 years later, actually the next batch, the next coming year intake, right? We are bringing it back. No, because very simple. Without that, you can't do a lot of things. Without that, you can't do a lot of things. Because you don't have the mathematical tools for your help. So let me just give you a very simple argument. Let's say here, okay? For example, let's say we talk about patient. Okay, is given a drug, okay, at the rate of 2 milligrams per 2 milligrams, let's say 2 milligrams per hour. Okay, is the next part is easier. How much is given in 24 hours? If the patient is given 2 milligrams per hour, how much is 24 hours?
24.
So what's the answer? You are correct. Answer is actually just 48 milligrams. Okay. Reason why? 2 milligrams per hour is actually the gradient. If you plot it out, correct, this is hour. This is the total dosage. Here, the gradient is actually 2 milligrams per hour. After 24 hours, what you are trying to find is the area under this curve. Okay. Now a lot of drugs are not given this way. What happened if I tell you a slightly different story? Do you think the drug given to a patient, the patient doesn't metabolize the drug? Do you think a patient will metabolize the drug away through your cytochrome P450 pathway and all this, right? That's your liver metabolysis or your kidney filtration. So I tell you that the patient, okay, just don't talk about liver metabolysis. I just use kidney. Okay, the patient actually excretes 10% of the dose per hour. After 24 hours, what is left? So what you have is the total total medication over time is first your 2 per hour, right? You minus off, yes, 0.1 of the drug dosage. This is the equation. Then to calculate over 24 hours, you integrate the whole thing, 0 to 24 hours dx. So fundamentally, the patient, and then you can ask, how long does a patient needs to take to be on steady state? That means the drug remains constant at the level. Your drug dose will be constantly at the level. Then the amount that you give versus the amount that the person metabolized have to be the same. Otherwise, you're killing the person. How are you going to calculate that? It's very simple because the question is all these are, and if you are actually in the hospital wards, you have to calculate all this by your head. Yeah, find the gradient. Right. You have to find when does it tapers off. Okay. So very simple. Last year, somewhere in June last year, my nephew went to hospital because of urinary tract infection. Then he was like 6 months old. Okay. So
6 months.
Yes, 6 months old. Okay. So 6 months old. So now it's 1 year old lah. Oh, anyway, what happened is that time he was drinking about 5 bottles of milk a day. So 5 bottles of milk, about 1 liter of milk a day. Quite a fair bit. Now he's drinking, because every time your 8-ounce milk bottle is 240 ml. You can drink a few bottles a day. Milk, okay? But because he was in hospital, he's given IV drip. Okay? And his IV drip is glucose, right? So technically he drinks less milk. So from 5 bottles of milk, he drank down to about two bottles or so of milk. So my brother was asking me, is he drinking 2 liter milk? Then I look at the IV drip. The IV drip is dripping 30 mils of solution. IV 30 mils. No, it's actually you type in. It's actually type in the number. 30 mils per hour. 30 mils per hour. Then I look at the bottle, the IV drip. It's actually 2% glucose. So then you reverse calculate the whole thing. He's actually consumed just by drip alone. He's being dripped 25 grams of sugar in a day already. So that is about 2.5 bottles of milk worth of sugar. So you add up, he's still drinking okay. If you transfuse too much glucose, his glycolysis just go haywire and he will burn himself out. If you go too little, if he's actually sick, he won't get enough glucose. So what is the correct balance? So do it. And you just have to sit there, stand there and look at the number. Does it make sense? You differentiate, integrate, and differentiate, integrate. Basically, you have to look at what is the curve. Because all these are rates. All these are rates. Okay? So if you want to do anything, this is what happens to you. Okay? All right. So let's get there. Yes, let's get there. Okay. So the next part is assuming that we have this problem. Back to the height again. The mean height or the mean length is 150 cm. Okay. The standard deviation of the length is 22 cm. So can you actually find what is the probability that the length is less than or equals to 141.2 cm? $141.2. Okay, so you use a normal distribution to help you find. So normal distribution, there is the x value, which is the number that you want. X value is actually the number that you want. Mean and standard deviation. Okay. So x is 141.2. The mean is the 150. Standard deviation is 22. Then it asks you whether you want the cumulative or not. So you want the from lesser, anything that's less than 141. So from 0 to 141.2. So you want the cumulative, which is true. So that gives you 34.5%. True, yeah. Okay. So which means that what you end up here is this. This is your normal distribution. This is the length. Here is 150. So 22, 78, 50, 70, 172. What is 150 minus 22? 22. 128, right? Okay. So what you have is 144.1. Okay, so let me just expand this line a little bit longer. So let's say you have here 16172, 128, right? Okay. So 141.2 somewhere here. So this is 141.2. Okay, the area under the blue color is actually 0.34. Is it 4? Yeah lah, estimate lah. 448. 4, 6, about 1, 4, 3, 4, 4, 6. So that's area. Okay. All right. Then, can you find P that is less than, let's say 166? Try this yourself. Okay, so you get 0.7665, about that. Okay. So what it means is 166 will be somewhere here. So this is about 166. 7665. So here is 0.7665. Okay, so here we use a different color. It's orange. So which means that this area is 0.7665. Can you find what is the area that's covered by the orange alone? So what is essentially, what is the area here? Just minus off. Yeah. So the probability of 141.2, 166 is actually the probability of less than 166 minus the probability of less than 141.2. So then you just minus off 0.7665 minus 0.3446. Okay, that gives you the area of this part here. Okay. Yes, what? Yeah, larger than 141.2. This x is larger, ma? X is in between here and here. It's just a range. So you can do that. Similarly, you can do the opposite. Okay, what do I mean by opposite? Let's say, back to here again, the length is 150. Okay, standard deviation is 22. Okay, let's say that I want to find out what is the probability of getting less than 0.2. So what is this value here that I want to find out? So I have to reverse it, right? Technically, I can still use this equation if I really want to, but then I got to try and error. Make sense? So I can say that I want to say that the length below x that's equals to 0.2. to 0.2. So what is x? I can play around with it. So my normal distribution. So let's say my x, okay, I can say that, okay, maybe it's 130. Then I have cumulative true. It's almost there already. So if I have 130, it's nearly 18%. Testing. So 130 is 18%. So maybe I try 131. Now 19%. I can go indefinitely to do it, right? As see how many decimal points, how many, what kind of precision I need. Okay. So I can even go to 131.5 and see what happens. Oh, just quite nice. Okay. Or I can do the reverse. There's also a function give you the probability. What is the x-axis? What is the axis? So that is called the normal distribution inverse function, IMV. Just now we had that already. So it calculates the probability you need to give it. So the probability you have is 0.2. The probability that we want. The mean is 150. Standard deviation is 22. Okay, it's exactly 131.484. Normal inverse. Okay. So which means that this is exactly 131.484 centimeters. All right. Okay. So with that, why not you check for question number 6? Question number 6, you are asked to verify that your normal distribution, okay, let's say this is a normal distribution. Normal distribution, the mean is 0. Standard deviation is 1. Okay. Okay. So -1, -2, -3, 1, 2, and 3. Okay. What you're asked to verify is this. Plus minus 1 standard deviation is 68.26% or 0.6826. Plus minus 2 standard deviation is 95.46%. And plus minus 3 standard deviation is 99.73%. Why not you verify this in Excel? Okay, I'll do the first one for you. So my mean is 0. My standard deviation is 1. Okay. So my p-value, that is a standardized normal distribution. Yeah. Okay. Because there's a different scale. One is it is the difference between your the waste compared to a standardized waste. So a standardized waste, this is exactly what we do. We convert from one scale to the other scale. So it's similar to doing this, okay? Let's say this is a Z scale. Just now what we have is the length scale. The length scale, this is still 150. This is plus 22, so it's 16172. This is minus 22, so it's 1 to 8. How do you convert between these two scales, these two axes? So between 1 and minus 1 and 1. Okay, so you can use your normal distribution. The x is for, you take 1, then minus 1. You take, it's exactly what I did here. So what you're doing is this. What you're doing is getting this whole range minus of this range to find out what is this range. Okay, you are taking the red or the orange minus of the blue to find just orange. Okay, similar context. Okay, so you take 1, mean 0, standard deviation 1, and then you want the cumulative minus of the normal distribution again, which now is minus 1. So that's it. Okay, so you get 68.26, 68.27. That is basically what we expect for here. So why not you do the other two yourself? My answer is this. So now what I'm trying to get you to do is for minus 2, and minus 3. Oops. Okay. And your midterms is from which topic? 1 to 5, yes. So now you're at topic 3 only. Today you're supposed to do topic 4 for yourself, as in the lecture. Yeah, I supposed to listen to the lecture of topic 4 this week already. So next week is topic 5. Okay, so why not you do it yourself and get these two answers? So you have to think in your head which one minus which one. Yep. is from 0, negative infinity to 2, negative infinity to minus 2. So you have to think in your head, what is the boundary? Which one minus which one? You draw it out on the. Oh, it's the other way, the other way. All right. Okay, then if you know everything, that's all for today actually. This one? What B6? Oh, this one. This is my try and error. Yeah. Because if you do not know the inverse, then you really have to try and error for each one now, until you get the as close as range as possible. Okay, that's all for today. Yay. Okay. Stop my recording now. I just have a new interest to develop